Are you still using virtual machines? Start using Docker. Docker is a super valuable skill. Containers start up much faster than virtual machines and take much less space on your hard drive. Let's learn Docker right now to make our lives easier. Why should you use Docker? Docker makes it super easy to deploy applications consistently across different environments. It isolates applications, preventing conflicts between dependencies, and it allows developers and sysadmins to automate deployments and scaling. On one host, you can run multiple different services without worrying about conflicts between them because everything is isolated from each other. We will be installing Docker, running containers, managing images, working with volumes, networking, learn useful Docker commands, and cleaning up Docker resources. This will be a two-part video. In part 1, we have a look at Docker in general and how Docker works. In part 2, we will upgrade to Docker Compose. In a nutshell, with Compose, you can configure multiple containers in a single file and then start and stop those container setups with just one single command. Consider subscribing so you won't miss it. But let's focus on those Docker basics first. All commands that we're using today are available for download in the description down below, just like always. To install Docker, we're going to follow the installation guide from docs.docker.com. And the good thing about that is it already comes with Docker Compose, so there is no need for an extra installation there. So let's jump right into the terminal. First things first, as always, if you want to install something, you run apt update first to update your repositories. After that one, we're going to run this command to update our certificates. Also done. And after that, we need to install those key rings. Easy as that. And after that one, we're going to run this curl command to download something from docker.com. It's super fast as well. And after that, let's change what we just downloaded. And after that, we're going to add the repositories to the apt sources, just like this. And now that we added it to the apt sources, we can run an apt update again. So all packages are up to date. And after this, we can start using the apt get install for Docker CE, Docker CE CLI, container IO, Docker build plugin, and also, last but not least, the Docker Compose plugin. So let's run this. It's already installed here for me. And just to make sure, after that, we're going to run systemctl start Docker and also enable Docker. So now if we run systemctl status Docker, it shows us that is already running. Mine is running because I already have some containers in there. And to check if everything is installed correctly, we can do docker -- version and also Docker Compose version. So those are the latest versions as of today. And to really check if you can run Docker containers, you can do docker run hello-world. And if this message shows hello from Docker, this message shows that your installation appears to be working correctly. So now we can start learn something about Docker and Docker Compose. Let's start with this one, docker run -it for interactive, and then let's use alpine and use the shell. Alpine is a super small Linux distribution and it doesn't know the image for this as well, so it just downloaded it again. As I said, it's super small, just this one pull. And now we are running alpine in here, and the installation was super fast, not even 1 minute. And we have a whole new Linux distribution here to play around with, and we can exit this And now we're back in our Ubuntu server. But let's start up something more useful. We can do docker run dash D for detached, so it will run in the background, so we have our command line for ourselves. And we can define the port 8080 to 80. That means everything that arrives at port 80 at our host Linux server will be forwarded into the port 80 inside this container that we're creating here right now. And I want this to be a container with the image from NGINX. NGINX. You need to write that correctly. It tells us again it can't find it because I haven't started NGINX in here on this Ubuntu server before. So it will download it. As you can see, it's a bigger, so it needs to download some more layers here. And now it is done. It tells us here this is the container ID, and we are back here in our terminal. So now how can we see if that is really working and running? We can switch to here, and if we go to the IP address of our Ubuntu server, in my case this one, 194, we specify the port 8080. It shows us the default page for NGINX, because remember, everything that arrives at port 8080 of our Ubuntu server of the Docker host will get forwarded into the port 80 of that NGINX container. And port 80 is obviously HTTP, and NGINX is a web server, so it listens to port 80. And what we can also do is, now that we already have this image here, we can run that again, specify the port 8081, for example. Now the deployment was super fast. It's already done here. Let me copy this here, paste it in, go to port 8081, and we have two web servers now running on this Ubuntu server. You can see port 80, port 8080 and port 8081, and I can do this again to get a third one. And now we have three web servers here running at the same time without them crashing into each other, which is super nice, and the deployment is super fast, just like this. We can do more than just NGINX or web servers in general. We can do a MySQL server if you want. We can do docker run -d for detached again. We give it a name. Let's call it MySQL server. We pass some variables in there. MySQL root password equals root, and the port for MySQL servers are 3306. We just take that because our Ubuntu host doesn't have a MySQL installed, so the port is free. We can start this. I have an error here because I forgot to specify the image for that. So now it knows which image it should run, the MySQL image, which it doesn't have, but it can download it from Docker Hub. And now that this is complete, it started a MySQL server. I don't have a MySQL workbench on this computer here, but trust me, it is running and working, and you can use it just like that. Let's start up something else again. We can do docker run -it for interactive, and we can start up a Ubuntu server again with the bash terminal. It will download it again, but what this does is it will start another Ubuntu server inside our Ubuntu server already, and you can basically treat this as a sandbox. You can try some commands in there. We're already in. You can install different stuff here, for example, there is no tmux in here, but we can do apt install tmux. Did this work? I'm not quite sure. But basically, you can do anything you want in here. We can run rm-R star, which you really shouldn't do inside your Linux server, because now we deleted everything in here and basically you can't use that server anymore. But since this is just a container, we can exit this and we are back in our host. All right, now we know how to start different containers. You can check on Docker Hub. Wait, let me just this here. You can go to Docker Hub and check out different images in here. There's so many. There you can run Olama if you like. There's Alpine, there's NGINX, MySQL. You can do MongoDB if you want, Grafana, everything. You can just click it and it will show you the documentation and how to run it. The Grafana image is surprisingly small with that documentation, but you get what I mean. You can try out different images. But let's check some useful Docker commands first. We already started up some containers, but how can you see them? How can you check them? You can use the command docker ps and it will show you every container that is running here. Maybe I can do main screen, do this down here. This is easier to read. So you can see which image it's using. For example, here in my SQL image, when it has been created, how long it's been running. You can see the ports. For example, 3306 will be mapped through 3306 into the container. TCP protocol, and the name is the MySQL server, just like what we did earlier. And you can also see the 3 NGINX containers that are running with the port 8080, 8081, and 8082, all going through port 80 inside the container. And we didn't specify a name here, but Docker just comes up with some names of themselves, like suspicious blackbird. You might have noticed our 2 other containers didn't show up here. We can do docker ps-a for all, and in here you can see our alpine container, for example, which we exited 12 minutes ago, and our hello world container, which we exited 13 minutes ago. So they are still there, they still exist, they're just not running. So with docker ps, you can see what's running, and docker ps-a, you can see every container. So now what if you don't want your MySQL server anymore? You don't want, you want to keep it, but you don't want it running right now because you want to try something else. You can do docker stop and then either use the container ID, but we have a name for that container, so we can just use the name and it will stop it. It will respond with the name of the container that has been stopped. So if we do docker ps, it's not showing us the MySQL server anymore, but if we do ps-a, then the MySQL server is still here. And if you want to start up the MySQL server again, you can just use docker start. And now if you do docker ps, the MySQL server is running again. But let's say you really want to get rid of this container, of this MySQL container. You can docker stop MySQL server, and then you can do docker rm for remove and use the name again. And now if we do docker ps-a, the MySQL server is not showing up here anymore at all. So it's really the container, the whole container is just gone. But you don't need to worry because you can just use the docker run command wherever it is here again. And to see it's a different one, we can do a different name. And now we have a MySQL server new here again, which again we can this one we can stop once it's stopped. Any second now. Now it's stopped. And now we can docker remove MySQL server new, and we remove this container again, just like this. Earlier we downloaded a bunch of images. You can have a look at them, what images are available with Docker images. It will tell you you have, for example, here we have Alpine, NGINX, Ubuntu, MySQL, and the Hello World image. And you can see when they have been created, not created on your computer, on your Linux server, but created by the creator of the image and that uploaded it to Docker Hub. And there's different tags. For example, you can have a different NGINX version if you want. You just use a different tag for it. You can see that in Docker Hub, which tags are available. And let's say you don't want this Hello World image anymore because this 10.1 kilobyte are very precious to you and you want to use them. So you can do docker rmi for remove image and use the image name Hello World. It tells us we can't do this because docker ps-a because the Hello World is used by this container. So we just docker stop this container and do docker remove this container. And now we can remove this image. And now if we go to Docker images, we don't have the Hello World image in here anymore. And we freed up that, how much was it? 10.1 kilobyte. But you could also pull an image without running it. So you can do docker pull Hello World. It's working. And now if we have Docker images, then we have our Hello World image here again, ready to use. And if you want to have a more detailed look at an image, you can use docker inspect. Let's stick with Hello World, and it will show you a bunch of information in here about this image, and we can try to inspect another one, for example the Ubuntu one. We'll just give you some information about the image here. One thing to keep in mind about Docker is if you run an image, if you start up a container, everything you do inside the container will be gone the moment you remove this container. So for example, if you have a MySQL server and you have a bunch of stuff in your databases in there, once that container is gone because you restart your host or something, then the data is gone as well. But to prevent this, you can use volumes. What a volume is, it's a folder, a directory on the Linux server host, and we will map it through into the container. So everything the container is writing into its own file system. In that special place, it's mapped through, so it will write everything into the Linux server host. So once you get rid of the container or anything, the data is still there, so it's persistent data, and you can start up the container again with the same volume, and it will be as if the container has never left the server at all. To create a volume, we can do docker volume create data. We can check this with docker volume ls. We have here our data that we created. And to use this, we can just docker run -d -v, -d for detached and -v for volume. And let's use the data and map it through into the container, into the directory data. Let's give the container a name, container, and use the Ubuntu image for that. And now that container is running with this data folder inside, but everything that's written into this data folder will be written into the volume, which is located locally on this computer. And the volumes are in cd var lib docker volumes. Let's have a look. There is data, and in here there is data, and in here there is nothing. But if we create a file in here, now this file will be available in the container as well. And we can also use the inspect command, docker inspect, let me just docker volume inspect data, and it will give you information like the creation, the driver, the mount point where it's located, and stuff like that, and the name for sure. Docker also allows us to create networks to isolate the containers even more, or to enable different containers to communicate with each other, to put them all into one network. We can use docker network ls, for example. There is already 3 networks by default from Docker. One the bridge, other one is the host, and the null one. We can also create our own network. We can do docker network create, sorry for that, my network. And now if we do network ls again, then you can see my network. By default, it's always a bridge driver, just like this one. And what Docker does, it's really cool. Once you put a container into that network, it will readjust the IP address of that container. You don't have to worry about that at all. It will do everything by itself. Even if you change the network, if you add more hosts to it, Docker will handle this by its own. It will adjust the subnetting and everything. So there is no IP address conflict there at all. We can also use this network for a running container. So let me just docker ps again. Let me use this as container ID for one of the NGINX containers. And then we can do docker network connect my network to this container, and then that's already it. Now this container here, it's in this my network, so it's more isolated from those other 2 containers. And since you can connect a container to your network, you can also disconnect it from it. You just use the command docker network disconnect, then the network you want to remove, and the network and which container you want to remove it from. Just enter, and now it's already done. And the container is not affected at all by it. It just keeps on running the same. You don't need to reboot it at all or anything. But that doesn't mean you can't reboot it at all. For example, you can use the command docker restart and use the container ID or the name. And then if we do docker ps again, it will tell us this container, this one NGINX here, is up 3 seconds ago because we just rebooted it. We can do that again, and up 1 second again. Just like that, it's super fast to reboot those. Not like when you want to reboot a whole Linux server, it takes a minute or 2, but this one is even faster. And for debugging, you can also check some logs, for example, docker logs. Let's see if there is anything at all. Yeah, there is. You can check some logging for that container. So if at any point one container won't start up at all or will have some difficulties, you can always check the logs. And what you can also do is you can change into the container with docker exec-it, then the container name or the container ID, and specify what terminal. For most cases, the bash terminal will do just fine. Now you can see we are root at this container ID, and we have control over this container here. We can change into here NGINX. Let's see what's here. Conf d ls cut default. This, for example, is the default page that we saw in the browser. But keep in mind, anything you change in here, since we don't have a volume mapped for this NGINX container, if you change it in here, if you delete that container, start it up again, it will all be gone. So for NGINX, it's better if you map a volume there, but I will have a video coming up for that, how to set that up, especially as a reverse proxy. So stay tuned for that. And now to clean up our Docker or our Linux host here a little bit, we can stop everything first. We can stop all those containers first. And also the suspicious one. And then we can remove all stopped containers. First of all, let's check none are running, but we still have some stopped one. So we can do docker container prune, it says, and it will warn us we will remove all stopped containers. Let's continue. And now there is not a single container left here anymore. We can also do this with the images. We can docker image, if you spell it right, image prune. Warning again, it will delete every image here. And then we can do docker images, still here, docker rmi star, doesn't allow it. Okay, this one doesn't work. I don't know why, but we can do remove image and remove them one by one if we want to. Let's try this one out. Docker network prune. Let's see, and then this one works better than the other one. It says it deleted the network, my network. So if we go docker network ls, I think, yeah. Now it's not showing us the my network anymore. And if we want to remove everything at once, we can do docker system prune -a. Let's see. It will delete all stop containers, all networks that are not used, all images without at least one container, and every build cache. Let's see how it looks like. It's already done. Now it's all gone. So if we do docker images, now they're truly gone. But that is the nice part about Docker. Even though everything is gone, as long as you have your volumes, for example, you can just start up the containers again. Even though you don't have the images anymore, if there are Docker Hub images, or if you have your own image, if you prepared your own image, you can just pull it again from Docker Hub. We will do that too. And you can use your containers again. But as I said, this is a two-part video. So here in part one, this is just to get an understanding of those basics in Docker. So you know what an image is, you know what a volume is, you know how the port mapping works, you know the networking of Docker, and you know how to start up containers. But in the second part of the video with Docker Compose, once you upgrade to Docker Compose, it will be super, super easy because you just type it all in one file and you can define everything you want. those environments, those ports, those volumes, the networking, everything, and you can start it up with just one command, and it's just super easy and it makes your life so much easier. So stay tuned for that. Once it's uploaded, you can see that here on the screen to watch it. And up until then, thanks for watching. See you next time.